shall we?
Let's do.
Welcome to the Hackaday podcast. My name's Mike Szczys. I'm editor-in-chief of Hackaday.
Hey, I'm Elliot Williams. I'm managing editor of Hackaday.
This is episode 106. Today we're talking about a connector kerfuffle, tuning fork time, Spinach contact prints, and Tesla's permanent memory. Oof, the grid down in Texas, Elliot. They were certainly not prepared for cold weather this week and are in a real bind. And actually, I shouldn't make light of it. The inability to heat your house or apartment is leading to some loss of life. I read about a family that had, I guess, tried to run their car in the garage to help heat the house up and had carbon monoxide poisoning and some other stuff. Boy, it's a real mess. It seems that over the weekend, they had a real bad ice storm. I guess for anyone that's not in North America, there's a huge polar mass of air down the center of the country, all the way down through the United States and into Mexico to the point that you're like below freezing in Houston, which is just bonkers. But yeah, it knocked a whole bunch of power generation off of the grid at the same time that people were, using more electricity in order to try and heat their homes. And so we saw some wind power fall off because of ice. But interestingly, there was a lot, the bulk of it was natural gas, coal, and then they said nuclear. And I think they said nuclear. And I think we should.
In Texas, they actually said nuclear.
Yeah, there you go. We should unpack that a little bit because I was surprised. Were you surprised to see that natural gas would be affected by the cold weather?
Yeah, I was going to say, well, tell me why coal and definitely tell me why nuclear.
I'm not sure on nuclear, to tell you. Maya Posh, who has written a ton of stuff on the nuclear realm in Hackaday, got into the comments and said that there was one plant that was down for scheduled maintenance. So it might be that's it. But I saw another report, I think in the Texas Tribune, whatever the Austin newspaper is, where they quoted someone saying that there was one nuclear plant that was affected. So they may have gone down for a little while. I don't have good reporting on that other than a couple of different reputable sources quoting people from the energy sector that it was a factor. But what I did go and look at is the natural gas production. It relies on wellheads bringing the natural gas and then pipelines delivering it. And those are not made for robust use in cold weather. And so the wellheads freeze up. There are valves that freeze up. Pictures that I saw of some of what I assume are the worst places were showing just sheets of ice and, 3-foot long icicles where it had obviously been raining right around that, 32F0C temperature and completely freezing over structures.
And I suppose if stuff isn't designed for it, then, it's a real surprise when it does happen.
Yeah, so they were under about 46 gigawatts of production that they needed in order to keep things running. 30 gigawatts of that were were from gas, coal, and nuclear. The interesting thing is 16 gigawatts of renewables, so wind turbines, were missing. In Texas, had about 25% of their production in 2020 was from wind power. But interestingly, they don't count on it in the winter because they know that these turbines are not winterized. And so they only expect about 7% of their needed winter production to come from the wind farms. And we were talking about this. It's like, well, what's the deal? Because there are wind turbines in the North Atlantic, right? There's cold places that have these. So I did go and look it up. They have de-icing systems based on like carbon mats on the blades themselves that they can turn on, but they only install those where like ice is a constant problem. And instead in Texas, I think the plan for the renewables was, well, we have natural gas and coal and nuclear. We'll just rely on those and shut the wind farms down when they ice over.
That makes sense from a cost perspective. Winters are short, pleasant, and really not very cold in Texas. And it's not like here in Germany, they have a lot of wind farms in the North Sea. It's really, really, really cold. And they run all the time. But yeah, you must be right. They must be heated.
Go read Jenny List's coverage on this story. It's really good. Ran on Tuesday morning. The interesting thing there is she talks about the isolation of the grid. So Texas runs its own grid. It's not connected to neighboring states. And so you think, well,
Don't mess with Texas.
yeah, well, you think, hey, Oklahoma, throw an extension cord over so we can get our grid up and
Yeah,
running.
you don't.
And that's what you do if your house is out and your neighbor had it, right? Your neighbor would help you out if your family needed heat.
I suppose.
So Jenny goes into it. It's an interesting problem because interconnects between unrelated networks tend to be DC because the phase of alternating current on two different systems has to match perfectly or you cause big troubles. And so if you have a big grid in Texas and a big grid, say, on the western half of the United States, and you want to connect those together, you would have to shut down the entire Texas grid, or you'd have to somehow shut down one plant on the Texas grid and then have that plant disconnect from it and then connect to the new one and then bring it up at the same phase.
Or slow down, I guess. I mean, I don't know how easy it is to control the kind of aggregate phase over a whole net like that. But you could, you slow one down until they come in phase and then you could bring them back up.
Yeah, well, they talk about, adjusting, injecting cycles so that your clocks run perfectly.
Yeah, because they do that all the time. I guess I was reading in England, they have their clocks run faster and slower by accident because when there's more draw, the generators run a little bit slower because they're just chugging along a little bit slower because they have more load on them. And you can actually measure this and use it as a statistic to kind of keep track of the health of the power system. But that's because they just have one grid.
Oh, that's interesting. No, I'm used to the concept of, if you have a higher load, you can droop your voltage, but you're saying you can also droop the frequency?
I believe it droops automatically.
Huh.
This is not my industry, but I have read that it drops when under higher load.
So obviously we're not grid experts, but I did enjoy reading the story, and oh boy, I hope it warms. I mean, it's super cold up where I am right now, but our infrastructure is built for that, right? So, boy, I hope Texas gets out of this because cold's dangerous, and they're opening up heating centers and that sort of thing. But, getting around, they showed all kinds of car crashes down there, and then keep not dying from exposure to the cold, to the elements. It's a serious situation down there.
Well, my first hack this week is an unexpected controversy and a beautiful 3D print. This is print-in-place wire connectors aimed to make wiring easier. Tomasz Harvey Madrunchka's connector is a beautiful print-in-place connector that makes a quick connection between 2 or 3 wires without soldering them and is fantastically handy to have in your toolkit. I would say its aim is to copy the kind of popular Wago lever nut connectors, which are super popular here in Europe. Basically, you stick a number of wires, and they come in 2, 3, 5 wire varieties, into a bunch of little slots, a lot like you would with terminal strips, except instead of having to screw them all down each individually, which is such a pain, they have a little lever and you just go flip and then they all get connected. Inside there's a little metal bar that comes down, presses into the wires actually pretty hard enough to dent the copper and holds them together, making the connection. I guess this is an alternative to the sort of things that people in the States would use wire nuts for, right? And people in Europe, wire nuts are when you take 2 wires and there's a kind of a helix of wire inside a little plastic thing and you screw it together and it makes a nice strong connection. Wire nuts are awesome, but they still involve a lot more fiddling than these Wago clamps. And so there's a good reason that they're so popular here in Europe and why Harvey wanted to make his own. The thing I like especially about this design, it needs a piece of metal in there to bridge the wires you're connecting. And he uses a thin piece of copper wire that kind of gets wedged in the front of this 3D print. And then you push down a clamp and it has just enough tolerance to then push the wires you want to connect into this bus bar and hold them tight. The thing that I find most awesome about this is that you can clip this bus bar longer than it needs to be and actually then bend the pins down and solder it onto a board that you're working on.
That is such a cool trick.
I want to talk more about that in a sec, but what do you think about this one?
Oh, I think it's great. I mean, the bus bar being the thicker gauge wire is kind of brilliantly designed because you have to snap the clamp shut because that will kind of pry open where the bus bar goes. So it's held there by friction when the clamp is not in place. I don't know. So we're going to talk about the controversy, right?
Yeah, let's do.
Yeah. So people were up in arms about the safety rating for these. And I was kind of taken aback because I would never use this for my home wiring. It's even shown with like Cat 5, like the individual conductors from Cat 5 cable as the
Right?
example. So I would look at it as like wiring up a doorbell or, some other like low voltage where you don't even need a junction box type of thing.
Yeah, of course. And I think that's the ultimate use for this. What I found amazing about this was the kind of diehard religious dispute that's going on here between the Americans who insist on wire nuts and the Europeans who insist on these clamps, and neither side can see each other's point. And I think you should go through and read it just because it's amusing. Bring your popcorn. I'm an American who grew up in wire nut land, who lives here in Europe in Wago clamp land. And I tell you what, the clamps are pretty darn slick, and they do bite in there hard enough that you're not going to lose those wires, at least if you use the right size clamps.
They often come with like high-end light fixtures or ceiling fans here. They'll come in the box for making connections.
They're just hella easy. You
Yeah,
just
they're super cool.
fold them over. My God. Yeah, so that's the controversy. It's I think it's a lot to do about nothing, and I think you've got it spot on, Mike. This is not meant to be something with which you wire your house. You can buy the professional ones for that. If you're 3D printing it yourself, it's clearly for a project for you, and for that use, I think it's absolutely brilliant.
Yeah, like making connections on your arcade controller table or hooking something up to your Raspberry. Well, let's go back to the PCB though, because for me, having a print it yourself terminal block for your PCB is awesome.
Yeah, right? And a print it yourself terminal block with kind of an arbitrary number of common connections is even more handy. And I was actually talking about this the other day with Nicholas Roy, who is an artist. We've covered a lot of his work before on Hackaday. And he said, oh yeah, that piece I just did, the Smart Fairy Tale, links in the description. And he had basically, I've forgotten how many, 30 different modules, which are all kids' toys that are modified to do things. And they all wanted to be sequenced. And you should go look at his central brain board for this thing. It's like, scroll way down in his post. It's beautiful. It's a piece of plastic. And then he has basically everything hot glued onto it. And everything is like a Raspberry Pi and then just strips of these clamps. And the clamps are all basically fan outs from the Raspberry Pi. You can build the brain board based around these clamps and then just plug in your devices as you need them. And that's super quick and easy when you have this kind of big installation. But then this project takes it to the next level because you can, like Mike said, just solder these into a PCB. So you can get a PCB brain board made with the wires already going to where they would need to be and then put these clips in them. My God, it would be the ultimate prototyping rig.
There's a really cool clock this week, Elliot.
I knew you'd fall for this one.
You knew I'd want this one. All right, so
I loved it.
This is a tuning fork clock that Chris Slika built. Now, what is a tuning fork clock? It actually has the 440, the A440 hertz pitch tuning fork that you would bang on your elbow in order to test people's hearing if you're an old-timey doctor, or you'd listen to it and then try and tune your piano, or I don't know, what do they use these things for anymore?
Tuning your piano.
I guess tuning your piano naturally. So it vibrates perfectly at that pitch. That's its whole job, is to be a very simple yet precise machine. Chris took this and turned it into the timing source for a digital clock. And it's done really interestingly. So it has a 3D printed bracket that holds the kind of bone part of the wishbone shape that you would normally hold with your fingers. And then the two Y parts are left to vibrate by themselves, except he makes a good point. you don't want to have to go over with a little hammer and hit the tines every time you want your clock to keep going. It's like the digital version of winding a clock, right? And then I guess you also have to be able to measure the vibration electronically. And he looks at the problem. He's like, you know what? Guitars are really good at doing this. They have a pickup that ends up, sensing the vibration of the metal strings over the top of it. And so using an inductive style of pickup, you can sense the vibration. But if you turn that around and you actually inject electricity into that inductor, it will cause the tuning fork itself to vibrate. And so it is like a push-pull oscillator. It has an inductor to kind of push the times and keep them vibrating, and it has an inductor to measure the times and pull the clock signal.
The beautiful thing about it is it's a lot like a crystal quartz oscillator, and there the idea is it wants to vibrate at kind of a natural frequency. So you throw enough amplification in there to let it do that, to let it power itself. Then you throw in something like a bandpass filter or something to make sure it kind of centers around its natural vibrating frequency, or at least its first harmonic. And that's exactly what he's doing here, except instead of doing it with something that beats, 32,000 times a second, he's doing it with something that you can hear like slightly humming in the background at 440 hertz.
I was kind of put off by some of the comments criticizing the appearance of the homemade circuit board for this, Elliot.
Oh, what?
Yeah, people are like, oh, that looks it looks like a rusty nail or something like that. And I'm like, meh. You make it at home,
yes.
It's going to have some oxidation on it. And, if it conducts, it conducts.
I think he made it intentionally kind of retro. It's got that crazy coaxial cable coming out the front, and it's got a card edge connector at the top. I think he even describes it as such in his write-up. It's some kind of like retro futuristic something.
Well, it's certainly futuristic because he's got a custom character set for actually telling the time.
Yeah, right.
No, you mentioned quartz crystals. I think it's worth putting in here that Jenny did an article a few years back on how the crystal resonators work. And it's worth going and looking at that. It's funny to me that often you hear about a tuning fork resonator, but not because it uses a tuning fork, but because it has the two legs coming out of the single can and kind of looks like a tuning fork.
Chris said he got his inspiration for this from another tuning fork clock project that we had up on I.O. Lo and behold, we've even written it up on Hackaday. I should throw in the links to that. You might be asking yourself about the real gorilla in the room here, which is, how about the accuracy? And at the very end of his video, he's like, well, kind of a couple seconds a day. So it's not an atomic clock, folks. It's got a tuning fork in it. When it gets hot, it gets longer. When it gets cold, it gets shorter. You're going to have to live with that, I think.
You need to build a crystal oven for it.
Yeah, exactly. Well, no, he does put it in a bell jar, so it does stay kind of free of breezes at least and stuff like that. But my guess is that if you build something like this, you're not going for the hyper accuracy, you're going for cool, and that it is, right?
Certainly.
Next up, a hacky hack. Ghidra used to patch Fahrenheit into an air quality meter. B Silver Eagle bought an air quality meter because the parts of it bought in single quantity were just about the same price as the whole thing all together. And he figured, well, if I can't get it to do what I want, at least I'll be able to just take it apart and use them individually. What's wrong with this device? Well, actually nothing, except it shows the temperature in degrees centigrade and he wants it in degrees Fahrenheit. And thus, a reverse engineering project is born. People, man. I thought it was really lovely that he followed Eric Schlepfer's PCB reverse engineering workshop and gave it a shout out. Was that Remoticon?
Yeah, that was in November.
That was a great talk about how to kind of take pictures of a board and meld them together. And you can see B Silver Eagle doing that here. He has the top side and bottom side of this PCB and, playing around with opacity. You can kind of trace it out. Lets him find the SWD programming ports. The flash in the microcontroller wasn't protected, so he just downloaded it and got to work. Fire up Ghidra, start mapping things out. he really leveraged the function calling tree tracing function that Ghidra has. So you don't know what any of the functions are. They're all mysterious names, but you know which functions call which other functions, and you can use that to kind of map stuff out. And once you start getting partial information, once you figure out what some of the low-level functions do, it then becomes obvious what the upper-level functions do, and so on. And he uses this to trace the parts of the program that print out the temperature in centigrade. He then knocks out another function. I think it was one to change the color when the temperature gets above 55 degrees centigrade, which it's never going to. He knocks that out and uses that space in memory to write his Fahrenheit routine. And then he finds where it writes the numbers in Fahrenheit and goes looking for the sprite that would have the degrees C mark, and can't find it through Ghidra in the dump of the data. But then he uses, I think, my favorite trick of all time, which is to just plot the bits of the data out in ImageMagick and see if you can see any pictures in it. It's also really good for figuring out which areas of memory do what. So if you see a block that looks all the same, you can be pretty sure that it's a block, and there will often be a block and then a gap and then a block and then a gap. And this can give you kind of, a big overview map of the firmware you're looking at, but it also lets you see any images that pop out.
It's really interesting how often that trick gets used, because I've seen it with security researchers trying to tell if something is obfuscated or encrypted, and apparently if you see enough of these, you just get a pattern recognition matching that you can immediately tell what you're looking at when you plot out the bits like that.
I was looking at this, it was a long time ago now, this NeoNode 3D hand-moving position sensor thing, and I was like, oh, there's all this data. What is it doing? And so you just run it through ImageMagick, and boom, you could see your fingers waving in the air. Like, it's lovely to do that, and it kind of leverages our internal image recognition circuits, which are incredibly good. I guess the issues are you have to figure out how wide to plot the data so that things kind of line up in their natural way.
All right.
In this case, it was pretty obvious. I was trying to figure out the format of a synthesizer's save disk that I had, actually, and it had these really weird, like 73 byte rows for features, right? Like every patch was 73 bytes. And so you just keep changing the width of the picture, and then all of a sudden everything snaps, and you're like, aha, gotcha. And that's useful information in and of itself.
So now that we have this visualization of this, can I take this and turn it back into the binary?
Oh. I think so. I think it is the binary, right? Like, if you
that's wild.
Yes, it is the binary. You're just looking at the binary as a picture. So
you can see the glyph for the degree C too. It's kind of a puzzle in itself because they split it in half, and so you have the two halves are kind of like reversed.
The really fun thing to do, of course, if you want to experiment around with this trick, is to get like old Game Boy ROMs, like get Mario and just have a look at that, because all the sprites are in there just in data in the memory, and they just all pop out, and it's lovely to see the little mushrooms staring back at you.
Next up, we're talking about some photo finishing, Elliot, but not really with the kind of film that you think about, and certainly not with the developer that you think about. This is Spinach photo prints.
That's fantastic.
It is so fantastic. It is plant-based dyes that have a mask put over the top of them, like photolithography style, and then are put out into the sun for a long amount of time in order to fade before they're kind of set and then put into a frame for you to enjoy. It is absolutely bonkers, and I think everyone has to put this on their summer to-do list because it's so well explained and the outcome of it is so awesome. In this case, the presenter, Almudena Romero, shows a whole different list of organic compounds that you can use for this kind of exposure experiment, and it has characterized them by the amount of time that they take. So for instance, if you want to use turmeric and chard as your dyes, you can get a yellow-green image in a few hours. But if you want to use like blueberries, it might take a few months of exposure. in order to get this thing to work.
Why am I hungry all of a sudden?
Is this material science at its finest? It might be.
How long do the pictures last if you put them on your wall?
Well, the interesting thing is that at the end of the entire process, she waxes the photos so
Oh,
that as they dry out, you don't have the pigments flaking off. And she says that the photos will fade over time, but I think that they do keep reasonably well. The best thing is that if you've done toner transfer for circuit board production, you are totally set up for this already. It uses transparencies through a printer, and she actually recommends using two transparencies. So you take your image, you convert it to grayscale, you make it high contrast because you're going to get the best results out of that, and then you print two of them, put them on top of each other, and then she uses some piece of glass to put it in between with the paper.
sure.
In order to clamp it together. But that paper is really where all the magic happens. She has a whole litany of prep processes, which include, an immersion blender and high proof isopropyl alcohol in order to make a slurry that you can then paint onto slightly wetted paper. There's also the option to do it kind of like photo tray developing style, where you put the paper in the emulsion and you kind of gently tilt it around until it's impregnated the paper and then dry it on a line. A couple of different methods can get a couple of different results.
It looks so awesome. And man, I used to be a photographer back when there were chemicals. And it was really, really, really fun. There was always a little bit of like magic seeing them come out. One of the things I loved to do was pinhole photography, because you can expose entire sheet of paper and then you just flip it over and do basically a contact print like she's doing here. That's just the most basic, most kind of elemental photography. It's like, here, this captured this image. And so, real soft spot in my heart for this sort of thing.
Now, if you are someone who still has film and needs to get it developed, one of my all-time favorites is from a decade ago, and it is how to develop film with coffee and vitamin C. So we'll link that into the show notes as well.
Just when you think there's nothing new under the sun in 3D printing, Teaching Tech comes up with truck bed liners, improved 3D prints. This is a lovely idea. Nobody likes the lines and imperfections you get in 3D prints. And if you're trying to print something that's watertight, you have to go, how many layers? 5 layers usually I do. Man, what a waste of filament and time. Instead, you should just cover it with something. The question is, what? At the same time as running a great 3D printing channel, Teaching Tech is also working on a project car. And one of the things he was doing was fixing up some parts by coating them in bed liner. One thing led to another. He thought, hey, I wonder if I could coat my 3D prints in bed liner. And thus began the experiment. I guess someone else commented on his YouTube channel saying you could do this just as easily with floor sealer, bitumen-based floor sealer. And so he bought himself a can of that too to do the comparo. And so there's a little bit of a shootout here. But basically the story is, if you want to make your 3D prints tougher or kind of reduce some of the appearance of the layer lines or make them completely watertight, automotive bed liner is a fantastic product to smooth on the outside.
It's an interesting thing because the UV protection kind of sparked my interest on there.
Right.
Bed liners are going to be meant to be out in the sun. So if you're 3D printing a part that is going to be outdoors and exposed to sunlight, this would be a great way to give it a little more longevity.
And it gives it a little bit more impact resistance, and it definitely makes it waterproof. The thing I like the most, although it's maybe the least successful, he decided to test if it would give them any kind of heat resistance. And so he completely covered some statues of little people in bed liner and then the bitumen, and then left one raw as control and threw them in an oven to see when they would melt. And yeah, unfortunately, if you're looking for something structural, they all melt just the same because the PLA on the inside melts anyway. But if you do manage to completely seal your print in bed liner, you might actually get lucky enough that even though it's molten on the inside, you have kind of a solid bag of smooshy bedliner on the outside. I actually learned something here too, which is that a lot of these bedliner products are made of chopped up tires. And so they're basically chopped up rubber. I guess it must be super finely milled rubber combined with some kind of binder, and then you just paint that on. And it made me think there must be a DIY option for some of this. One of the other paints that he briefly considered was an epoxy-based bed liner. So it's epoxy plus chunks of cut up tire. And I thought that was kind of interesting. The one he ended up using has no volatile organics, tends to be more environmentally safe. Makes me think it's probably something like waterproof glue, maybe waterproof PDA with a bunch of car tires thrown in there. So I've thrown down the gauntlet. If you're into doing it yourself, crazy goop, I think that'd be fun to try.
This does also make me think of an article that Donald Papp wrote a couple of years back on smoothing prints with UV cured resin. That's certainly not going to be, the easily sourceable, inexpensive version of it, but it's an interesting read if you're looking for surface finishes that are out of the ordinary.
And the Prusa folks came out with a food safety angle on this, where they concluded that using a 2-part epoxy in a super thin layer over prints made them actually sealed up the holes and gave you a hard enough surface that you can actually wash it and use it for food stuff. So I think this is a really neat topic, and I was surprised at kind of how much extra toughness he got out of the bed liner for how little weight it ended up adding to the parts.
Elliot, I've always wanted to fly a helicopter.
Oh my God, death wish.
It seems so cool, but yeah, my risk aversion means it's probably never going to happen.
I think they're hard to fly. I'm not sure. I've never done it.
I don't know. I've flown a lot in video games.
Yeah. Oh, well, that would be good. See if you can find one with the keys in it.
Yeah, there you go. Well, Oscar RDA certainly has figured out how to fly a helicopter, and one that has been hacked to be a little bit different take on especially the tail rotor in this case. It's doing away with a single tail rotor and putting 7 rotors in its place. This is a Mosquito helicopter kit, which is an electric personal helicopter. I would say the rotors on the back are basically what you think of when you think of a quadcopter, except in this case, it's a septicopter turned on its side to keep the thing from rotating. It does make a lot of sense because the helicopter has that phenomenon called auto rotation. So if you disengage the main propeller from the motor so that it can freewheel, it will not just come crashing down. It's kind of like how a plane that's not powered can glide through the air, except in this case, the propeller will turn as the air rushing up, or it's rushing down past the air, goes past that propeller shape, and it will slow it down so that you don't have the same kind of crash you would if you were just in free fall. Compare this to the people who have been trying to build their own 12 propeller or 4 propeller, or however you want to look at it, passenger based multicopters, and it has a very good safety bonus to it.
I guess the one thing that strikes me about this design is that propellers get more efficient the bigger they are. So you get a lot more thrust out of one big propeller turning than you do out of 7 little propellers. And so I wonder what the trade-off there is.
So he says that he only needs 4 and that there are 7 for redundancy. And if you think about this, if you had one electric motor with a larger propeller on the back, but you lose that, you're going to have major problems.
When it fails, it fails. Right.
If you don't have that tail rotor, you're going to spin uncontrolled. So then you're going to have to disengage and do the auto rotation thing, because my understanding is the helicopter doesn't spin when it's auto rotating because you don't have a force that's turning against the air.
Right.
So if you lose the tail rotor, you can auto rotate to come down but it's still like an emergency landing. I don't know if that's the point of this one, but if you look at this thing, it's the ultralight of helicopters. Like there's nothing around the pilot. The pilot's just out in the open air. There is a pretty big battery, a 7.8 kilowatt hour battery, lithium polymer battery that weighs 40 kilograms underneath the seat that's, turning the big motor for the large propeller. But wow, watching him fly this thing, did you see where he's hovering and traveling forward over the tarmac, but then doing circles as he goes and still going in a straight line.
Spinning as he goes along. Yeah.
Do you have to like rotate the stick in a circle while you do that?
I have no idea. I think you probably don't actually. You probably just ease off on the counter rotation that's coming from the back. I have no idea though. Helicopters freak me out.
At any rate, it's interesting to see the tinkering on a multi-rotor that is actually a helicopter. That's kind of fascinating. And then I hadn't really looked into these kit helicopters before, but maybe someday, Elliot.
All right, my first quick hack this week, I'm squeaking two in. We've got a twofer on crazy modified piano compositions this week. First up, continuous excitation piano machine looks nervous, sounds grand. Composer Patricia Alessandrini and engineer Konstantin Leonenko put together a piano that is covered with little pager vibration motors that have paddles on them that sit down in between the strings. When the pager motor vibrates, the little paddle hits the two strings and goes whoosh, and it makes a fantastic eerie sound. And because they're all controlled by a computer, you can play different notes, and it makes this kind of swelling piano sound that's nothing at all like a regularly struck piano. A little bit more into the normal piano world, tiny motors enable experimental piano performance. This is a composition by Alessandro Perini and performed in the video here by percussionist Irene Bianco. She has motors attached to her hands and is both playing the piano by plucking it on the inside, but also by having the motors attached to her fingers hit the strings, and they're controlled by a Raspberry Pi. So it's this intricate dance of like human percussionist and computer controlled motors at her fingertips. Really interesting. Next up, Dreamflight customizable flight stabilization for your weird flying contraptions. We've covered some of Nicholas Rame's projects before. He's done vectored rocket-like things that actually are run by propellers, VTOL devices. This is a write-up of his custom IMU software that lets you control things that aren't simple like a quadcopter or an airplane. If you're into wacky flight stabilization, this looks like a good open software for you. And last up, Cluzy has built himself a volume control from a VCR drum. I actually have one of these in my junk boxes. I've always wanted to know what to do with it. They just spin so nicely. VCRs are an improbable piece of high tech that became consumer gear from a long time ago and are full of technical goodies. I was a little bit bummed here to read that he didn't crack the problem of how to get the spin signals directly out of the encoder that's on the VCR head, but that's some kind of weird coupled transformer and basically impossible to do. Instead, he just puts an optical sensor on it and uses it like an old school optical mouse, but it makes a lovely desktop controller.
First up on my list of quick hacks is PCB mod silences voltage warnings on the Pi 4. Bajenko was tired of playing MAME and having a low voltage warning coming up, and so fixed it with a 470 microfarad electrolytic capacitor that looks comical next to all of the tiny surface mount parts in the power portion of the Raspberry Pi 4. There's some good comments on this one, and people suggest that instead of removing the current limiting resistor that was done here, you could actually piggyback this onto a different SMD capacitor and not have to remove anything from the Pi at all. The good news, it fixed those warnings. Next up, we all wondered what was going to happen with the Raspberry Pi RP2040 and its PIO units. That is the chip that was on the Raspberry Pi Pico. Ellie wrote that great article about a few weeks ago. Here is a wonderful example by Luke Wren, where the PIO is used for DVI, video output. A very awesome hack, so check that one out. And finally, we have VGA without the hassle from your PlayStation 1. It's cool to think about how those OG PlayStations, the way back in the day, and I remember the first Xbox was this way, have a bunch of different video signals already available on them. And in this case, you can patch directly into the VGA signals on one of these original motherboards. You do have to find a monitor that will be able to support the kind of oddball 15 kilohertz signal that this generates. It's time for our Can't Miss Articles of the Week. This is long-form content written by spectacular Hackaday writers. Elliot, what did you choose this week?
This week, I picked Basic Cross-Platform Software Hacking Then and Now. This is a look back at what actually was my first computer language by Maya Posh. I don't know, is Basic dead? Is Basic not dead? Do you love Basic? Do you hate Basic? Do you still use it today? I think all of these are questions that cannot be answered with a straight face. Let's see. Do you want to do some basic nostalgia? What was your first programming language, Mike?
Well, I remember that at home we had an 8088, 8086. I can't remember which one. One of those two was the first computer, and it came with some version of BASIC on it. And I took a Saturday class at the middle school on, or maybe even was the grade school, on programming. I'm not sure if it was on this language or not, but I went home and I ended up figuring out how to draw a circle. And then I ended up figuring out how to make it loop so that it would draw a circle 4 pixels off of that. And so it was like that Spyro gyro stuff. And I remember going to my parents and being like, look at what I did. And then they're like, okay. And yeah, but it was amazing.
I would have thought that was awesome. Yeah, BASIC was my first computer language I learned on the Tandy color computer. What can you say about BASIC? It's a very simple programming language, but it still covers a lot of the fundamentals. And especially if you have a BASIC that supports Go subs and things like that, subroutines, you can actually write kind of okay code on it. I mean, you've got for loops, you've got if-thens, you've got ability to call subroutines. And then, of course, you've got what I consider the absolute pearl of BASIC, the absolute gem. You've got peek and poke, which just by themselves validate the reason you would want to learn BASIC today in my mind. Because what peek and poke do is they let you look at specific memory locations in the computer. And in these old computers, that's not just the RAM in which your program runs and in which your instructions are, but it's also all of the hardware that's memory mapped. And so, you can write bits to the screen or read bits from the screen using peek and poke or the sound card or whatever. It gives you this really extraordinarily low-level, hands-on, pushing the bits around view of the computer programming language that I think is useful for a lot of people it's not useful for you if you're going to do a modern computer science degree. If you're the kind of person who likes to break computer systems, knowing how they work under the hood like this is entirely necessary. And I think just for that reason, peek and poke are they're my all-time favorite computer programming language commands, I think.
I was thinking about this a little bit before the show, and I think this is kind of my grumpy old programmer moment. I think BASIC is a spectacular way for you to learn to think about programming, because there's no crutches in there. You're not going to get a compiler warning, as Maya points out in this. It forces you to write your own line numbers, which then you inevitably pay for when you don't put enough space between them and you need to make a change. And then you realize you don't have space to make those changes. So it kind of makes you think about that. And then when you start doing, like you said, the go to and go sub, it really makes you think about, compartmentalizing your programs and seeing how you can reuse that code again, because it's kind of so arduous to have to type all that stuff out. I ended up writing, because we had the BASIC interpreter on the Hackaday Belgrade 2018 badge that, Jaromir Sukuba did, moved heaven and earth to get that thing up and running. It was awesome. And I went about writing Conway's Game of Life in BASIC by typing it into that badge, and it gets hairy very quickly in that language. My grumpy programmer thing, though, is that, there's an essay out there about drum programming and how, like, you don't really learn the fundamentals unless you've done programming on drum memory. And so I do think that I
Okay.
have this like snapshot in my mind of what it's like to learn to think about programming, and that's not necessarily the best thing still today. So like, do I think we should be starting everyone on basic? I think it's interesting, but there may be better ways. And so if you start someone on object oriented programming instead of on basic, they're going to have their own experience, and I think that's good.
But back to peek and poke for a sec, because I really do like the low level aspects of basic, and those especially coupled with the interpreter that's so hands on gives you this extraordinarily interactive low level feel for the device. And I was so laughing when I got one of the early ESP32 boards, and it had a bug in the hardware that caused it to go into emergency boot mode sometimes when you connected some pins together. And in emergency boot mode, there is a copy of Tiny Basic, a basic interpreter. And I was laughing when I found that and talked to Sprite about it. And he said, "Oh my God, you found it." They put this version of Tiny Basic in the ROM to help them with chip bring up because it lets you access all of the memory map peripherals super fast and super easily using peeks and pokes again, but it also lets you write programs to exercise them all. And so they were doing this while they were kind of qualifying the chip in its earliest bring ups, and that's why they had a version of BASIC hidden away in the ROM.
Oh, that's wild. So it's like a mask ROM on the chip, like, or is it microcode that's flashed to it?
It's in the mask ROM.
Oh, wow. So it's still there.
Of course it is.
Oh, that's
And all you
awesome. I
have to
gotta
do
go
to
try
get to
that
the
out.
Tiny Basic interpreter is short whichever two of these pins are when you bring it up. I've forgotten when that is, but
I'm sure it's out there somewhere.
I remember there were some funny things about the syntax I couldn't figure out, like where it needed parentheses or... But actually, Tiny Basic, that is the basic that's in there, is marvelous. And you can download that right now and compile it on whatever computer you're running. It's a single C file. You just type make Tiny Basic and then you just type Tiny Basic and you're using it on your computer right now inside of 10 seconds. No ifs, ands, or buts.
I picked out one by Lewin Day this week called Tesla Recalls Cars with eMMC Failures, calls part a, quote, wear item, which is so bonkers, Elliot.
Oh, man.
So eMMC is basically flash memory. It's persistent memory. So if you shut off the device, whatever's stored on there is still stored on there. And so it's common, like you can get single board computers that have eMMC memory on it, and that's where you put the operating system. And in this case, that's exactly what Tesla did. They had a device on pre-2018 Tesla models that was running kind of the infotainment system, and it has an 8 gigabyte eMMC chip on it. The unconfirmed number that I heard was that about 6 gigabytes of that is the firmware itself. And it is logging. The Linux log files are being written to that eMMC as well. And there apparently are a lot of them. And so what you have with these solid state devices is something called wear leveling, which makes sure that you're not, writing the same file to the same location every single time, because they have some kind of life on them. I'm not sure. I looked and looked and looked for a data sheet on this chip, but it seems to be some special variant of the chip by this company. It is an automotive grade chip, but I couldn't find the exact model number. But I don't know. What would you say, Elliot? Like 100,000 writes?
100,000 writes is pretty normal
Yeah.
for eMMC.
So if you write up to that number and beyond that number, you can end up having those cells not respond anymore. So wear leveling makes sure you move where you're writing to. The problem in this case is it looks like there were so many log files being written that 2 gigabytes is getting overwritten quite a bit, even with wear leveling. And so you started in a window of, let's say, 3 years, some of these vehicles were starting to have failures on this, and it ended up shutting the screens down on them. And since the screen is used for things like turning your hazard lights on, there's no buttons on a Tesla dashboard, is what I understand. It's all through this giant television sized touchscreen. You can't turn your hazards on. I think your backup camera doesn't work, this sort of thing. And so Tesla has been asked to do a recall on this. And kind of their response was, this is a wear item that customers should have to replace.
The saucier title for this one is National Highway Traffic Safety Administration tells Tesla that they need to do a recall, and Tesla tries to totally weasel out of it because there is no way that an eMMC card, this is a ball grid array part, is soldered to a motherboard that's inaccessible to the user, is something that you're supposed to replace. And I think Lewin hit it on the head in his piece, saying, there's nowhere any instructions for how to replace this. They tell you how to replace the brake shoes. They tell you how to replace the tires. They even will tell you, when the batteries fail, you need to bring the car in. There's nowhere in there where they say, here's how you do the BGA reflow to get the eMMC chip off. I mean, I don't want to say this is shady behavior, but this is entirely shady. This is an attempt to avoid responsibility when it's going to cost your company some money to do so. And I have to say that in itself leaves a really bad taste in my mouth.
Yeah, and it's not an inexpensive repair either. It's something like $1,800 to get this.
Oh, it's a super cheap repair. The chip is 50 cents. You just go in there, ball grid array, reflow it. No problem. No,
Tesla's fix is to replace it. It's a stock module. Like, Tesla didn't build this module. It's a Tegra module that costs like $2,000 to take this in and get it switched. But yeah, if you had someone with BGA skills in the back room, swapping these out, I mean, of course, part of the problem is these cars are all over the place. If you just had some drive-through where you could get them all, everyone could show up on a Saturday and get all of these replaced at once, I think it'd be a marginally lower problem. But part of it is, if you look at the request for recall and then the reply to Tesla's, wear item claim, the government agrees and says, like, yes, this is a wear item. This could be considered a wear item, but not in the cars that are this young. And if you think about it, there are like brake pads and tires on the car. Those are the good like wear items. Windshield wipers, right? Light bulbs that burn out. Those are all like easily meant to be replaced. Things that might wear out on a car that are not easy to replace, like some cars have like a timing chain that keeps the engine going, and like if that thing breaks, I hear it does incredible damage, and it's not entirely easy to replace that thing, but there is a method for it. In this case, I think that they've just done the implementation wrong. They should,
yeah,
in my mind, like, the question would be, who's reading these log files? Are these log files like getting phoned home frequently or read by someone? I would guess not.
Black box in the event of a crash.
Oh, yeah. I suppose that's a good point. But I mean, it talks about like even stuff from the infotainment system is getting logs from the infotainment systems are getting written onto this. They did something in the firmware that they pushed an update that kind of helped slow the problem, but it didn't completely get rid of it. But in my mind, you should just turn debugging off. Write your log files all to dev null. And then in the event where you start having problems, take it to the dealership or have them push an over-the-air update just to your car that turns it on. You drive it around for a while until the thing happens again, and you write it down. It happened at this time, and then you have them troubleshoot it that way. I mean, I shouldn't be armchair quarterbacking the Tesla engineers, because I'm sure these are not novel ideas that I have. I'm sure they thought about this, especially because the expenses here. But of all the boneheaded things that you could do is put a car that's supposed to be on the road for many years with a log file that maybe isn't going to be read. Like, that just seems like a real like facepalm moment, and I'm surprised they haven't done more to fix it at this point. At the same time, it makes me wonder, are we going to have the M.2 slots for SSD hard drives in our vehicles?
What's an M.2 slot?
That's the like NVMe drive size. It's for like the laptop size card. It's a card edge connector. Isn't it M.2?
So you want to swap out the ROM in your car.
Well, I think that you should move this to something that's meant to be written to and read from often. If this had been done like that, if there was a card slot somewhere, Then you'd just take it to the dealership and they'd pop the dead eMMC chip out and put a new one in. The good news, Elliot, is I don't have a Tesla.
Right.
I get that they're awesome. Don't get me wrong. Like, I think they're an interesting vehicle, but things like this makes it feel very much like you're driving the beta version of a car. That's all the time we have for this episode of the Hackaday podcast. As always, we'd love to hear from you. You can leave a comment in our show notes, which you'll find at hackaday.com/podcast. You can email us, editor@hackaday.com. We live and die by the tips that you send us. So if you've done something cool or you see something cool, please tell us about it. tips@hackaday.com. And until next time,
keep on hacking. All right. Those sounded nearly synchronous.
as long as there's some type of zanius, I'm fine.
I said too much about that one, but I loved it.
I did say boneheaded a lot.
Oof. I can't remember if I actually said bullshit. Tried to avoid saying bullshit in this one. I think I said it in basic for some reason. There's nothing bullshit about basic. Basic is awesome.